Hello, so welcome to the second lecture of MCS 507. 507 is a course on mathematical, statistical, and scientific software. And the purpose of the lecture of today is to provide an introduction or also overview of the Python language. So Python is a scripting language with a very important and very large computational ecosystem. Um, so the purpose of this lecture is introductory. So if you have to use software for your research and you are kind of not really sure where to start programming, then Python is an excellent choice for reasons that it is being used as first programming languages. There are already excellent books available, but most importantly, for this course on scientific software, there are so many good scientific software libraries and packages available. Python is large, and I will confess that I do not understand and do not completely know everything about Python. I just give you my take. Also, one lecture is definitely, and even two lectures is not enough. I will not say much about object-oriented programming, only tiny little bit. Object-oriented programming will be the subject of the next lecture. Okay, so hello world. This is how we start. The complexity of a language is often defined as how many statements does it take to print hello world. Well, Python is a one-liner here. The language is dynamically typed, interpreted. It's a framework language, so the saying goes that Python comes with batteries included. So it is modular, so suitable also for large programs and object oriented. When we run Python, we can run this from within the shell as a calculator. We can also run it as a script and also inside a Jupyter notebook. So this lecture is still entirely from within this typeset, from the mindset of terminal based, but I could alternative also have shown a Jupyter notebook. On the course website, there is a corresponding Jupyter notebook, and you're more than welcome to actually go through this Jupyter notebook. So we have the source, which here is traditionally in a file that has the extension py. But it could also be a cell, a code cell in a Jupyter notebook, or it could be an instruction that is being typed into the shell. But either way, there is a read, eval, print loop. The interpreter reads the statement, evaluates the statement, and then prints the result of the evaluation. So often when you import a module, you will see that as a consequence of executing it, there is a PYC file. So that's the bytecode that is produced when translating and running the code. This is the Python virtual machine. Kind of the layer between you and the operating system. Every variable has a type, even though it's dynamically typed. In a statically typed language, you as a programmer, you have to declare the type. Here you do not have to declare a type, but every variable has a type. And how does the interpreter figured this out. Well, if you write something with 3 point something, then it will be a floating point number. If you type in x equals 3, then it will be interpreted as an integer. If you put quotes, single quotes, or double quotes around it, then it will be interpreted as a string. So there is the built-in string method. This is very, very useful. Every variable has a string representation. This is how it shows up when you print the variable. So, and what is important is that you can go from the value to a string representation, but you can also go backwards. From a string, you can go to the value, as is illustrated here at the end of this slide. So the eval command takes a string and interprets the what is the content of the string. So if the content of the string, as here in the example, can be interpreted as a floating point number, then the outcome will be a floating point number. Okay, so, and I should have said this right away. So the content of the slide here, this 3 larger than symbols, is the prompt. If you're running on a terminal window, you type in Python or Python 3, then you will see these 3 larger than symbols, which is the Python prompt. So throughout this lecture presentation, I will mainly assume that we are in a Python shell. So all the commands you can execute as we are going here through the slides. So what happens now behind the scenes? Well, every variable is located somewhere inside the computer. And inside the computer, there is address. The address defines the location. So I just said you can type in these commands here. The outcome of the ID, so of the ID of the variable name, will most likely and almost surely be another number on your computer. Even if you execute this multiple times, the address, this is where the operating system comes in when you have to define the location where to store a variable. For that, you need the help of the operating system. So that is the machine view. So we have that for every value there is a location where it resides. It's like the physical home address. So where you are currently, there's the location of where you live, where your address is. Also, every variable lives somewhere in the memory. The address, in some sense, is also the technical definition of the variable name. So when x equals x equals 3, what we actually are doing, we are making a location that holds the value 3, and x is a name that refers to that value. And that value 3 is an integer. It has a type, and it is considered as an object. So the logical representation to the Python programmer is that a variable has a value and a name. The name refers to the value, the object. Okay, so if you are a C programmer, or typically most implementations in Python are based on C, then you can actually do something technical. You can dereference a value. I'm sorry, dereferencing, going from the reference, from the ID, from the output of the idea, you can actually get to the value. If you are a C programmer, then this is an aha moment. Um, I have this slide here not to confuse people, or not to say that here is what you should do. This is what a Python programmer will never do. But I will come back to using references as a programmer. So Python is an encapsulation, but it has extra layers of abstraction that a C programmer doesn't have, but it doesn't mean that you are reduced in power. So you can still do the referencing, the sharing of references, which is a very powerful programming technique, as I will illustrate later. So we have built-in types. The types we know are the number types. So the integers, the floating point numbers. So numerical analysis takes floating point numbers as the prime default type, and working with floating point numbers is, how shall I say, rather interesting. There are the discrete types, so the integers and the booleans are the true false types. Strings are seen as also elementary types. So an elementary type is a type that you can't break up. Although, as we will see, you can actually break up a string. A string is seen as so Python doesn't have a character type, but it has a string type. And you can treat a string just as you can treat a number. A number, an integer number, 1, 2, 3, has many digits. So a string also has many characters. All right. Important here is that Python has very useful composite types, tuples, lists, and dictionaries. When one learns how to program, typically one introduces first the control structures. In Python, it makes sense to also introduce at the same time the composite data structures or the composite types, as I will try to introduce now. So in a way, this could be confusing if this is really your very first programming experience, but I try to make this also interesting for people who are coming from another language, as is most likely be the case now. So algorithms and data structures. So there is the classical textbook, which people of my generation have most likely been subjected to when studying programming. Programming consists of algorithms and data structures. In the first lecture, I indicated that a historical prerequisite was data structures. So data structures are still forming the core of programming design. That is why in a language such as Python, a modern programming language, it comes automatically with a lot of support for the most useful data structures. So here I have a table that makes a mapping between the most common control structures. So every program is a sequence of instructions. One can branch, one can execute certain instructions depending on whether certain conditions are holding, and one can do repetition, so one can repeat the same statement over and over again. Well, one can see a program as a way to transform data. The data is kept in data structures. One can see tuple assignments. One can select data based on a dictionary. So dictionaries and branching statements are kind of the equivalent from each other. And Python supports list comprehensions, which is another way of thinking about loops. So it makes sense actually to introduce the data structures, the built-in data structures, at the same time when we look at the instructions. So here consider a sequence of instructions. So A gets the value 1, B gets the value 2, or 1 gets assigned to A, 2 gets assigned to B. One can do this all in one assignment. So we have a tuple assignment. Tuple assignments are really useful if you have to swap values. If all of a sudden you want that A becomes the value of B and B becomes the value of A, if you don't have tuple assignment, you must work with a temporary variable. And that's already a first interesting programming assignment. So if you want to assign to A the value of B, you have to be careful that you do not lose the value of A, because that needs to be assigned to B. So think about this. So that's one of the classical programming paradigms. When one thinks about values and variables, this paradigm of using a temporary variable when swapping is actually not necessary, or is replaced by the tuple assignment in Python. So Python is one of its qualities is that you can write very short programs, very powerful programs. I mentioned branching. So if one wants to have a polite program that greets the user accordingly, we can do this depending on the time. So Python comes with the time module. We can get the current time, and depending on the hour, whether it's 12 or larger, we will print good morning if it's less than 12, or good afternoon if it's larger than 12, so that the hour works in a 24-hour format. So here you see the if-else statement. So Python, by the way, is sensitive to spacing. So here you see I typed this in. Normally you would actually type this into a .py file and run this as a program. But here I typed it in at the interactive shell, which is a little bit awkward, but the program is short enough to be doing this. So this is one if-else statement. That prints the good morning here. When I prepared this, it was still in the morning. Now it will be in the afternoon. But here you see that the if-else statement can be translated in a dictionary lookup. So this is kind of the cool thing of the analogy between a data structure and a control structure. In the data structure, we pre-program all possible answers and also the outcome of the comparison. So the comparison is done when we do the dictionary lookup. So the outcome of the hour less than 12 is a true or false, is a boolean, and that value is the index to the dictionary. The index of the dictionary, it then is used as the key in the lookup, and the result of the lookup is either good morning or good afternoon. Um, Dictionaries are extremely useful. Um, so, in a modern data structures course, one in a classical C-based data structures course, building a hash table and is actually quite an advanced operation already. And it could actually even be that if your instructor or if the students were too exhausted, you actually never got to implementing in C a proper hash table. In C++, there is the standard template library. So in also a modern data structures course, there is actually the mapping. So just to say that other languages also evolve. But Python has the built-in immediately from its pre-design. It was designed to include by standard the dictionary data type. Here is this is a table which kind of gives the most useful constructions. I should, by the way, say that when do you need a dictionary? When you construct a frequency table. If you want to see how many words occur in a certain text, you make a dictionary with as keys the values, which are the proper words, the strings, and then the values are the occurrences of each word in the string. From dictionaries, we can go to lists when we ask for all the items. That will return a list of keys and value pairs, or a new type dict underscore items, which you can convert into a list. You can also query all the keys and all the values. In the mathematical point of view, and this should be pointed out right from the start, you see the initialization here. The initialization happens with the curly braces. So you can see the dictionary as the mathematical equivalent of the set. So the order in which the items are stored are rather arbitrary. The order is determined, or actually not arbitrary. The order is such so that it's optimized for an efficient lookup. So again, I should have indicated this. So Python is dynamically typed. How does Python know that you are working with a sequence or working with a dictionary? Well, with the curly braces, like here, you work with a dictionary. If you use the round brackets, you are working with a sequence. So the round parentheses, you work with a sequence. If you use square brackets, you work with a list. So that's our next data structure. Here I will introduce lists also with loops immediately as list comprehensions. So if you want to make a list of all items, say of all odd positive numbers less than 10, then you can do this in one statement. We use the range construction. So we are for all the numbers x in the range starting at 1, ending at 10. So we give 11, not 10, because our indices start by default at 0. So the first element in the list is located at 0. So that gives us the reason why we stop at 11 here. Okay, so in more conventional programming languages, but this is equivalent to, so this is bad programming practice in Python. In Python, you can initialize the list and then append one after the other. If you want to do what we wanted to do, then the list comprehension is much more efficient, and much more efficient also in terms of expressiveness. So just one statement for a loop. If you ever took a programming language as a first programming language, then your instructor must have carefully emphasized that there is an initialization, there is a stop condition, and there is an increment. So the range stores these conditions essentially. Where do you start? You start at 1. Where you stop at 10. And what is the increment? You increment by 2. So there are a lot of things taken care of in the statements that are here. So again, if this is your first time programming, then this might be already extremely overwhelming. This is mainly intended as an overview and for those of you who most likely have already done some programming. If your programming was done in Python, then this could be indeed rather superfluous or rather tedious for me dragging you through this. All right, so let's try to do something important. So I mentioned references with the C Python, which looked kind of too technical and not at all appropriate in a first introduction. But here, let me point out how we can do the sharing. But let me first give you another application of list comprehensions. Also kind of showing how strings are an elementary type, but then also can be easily broken up. If you want to see all the decimals, so we actually ended the first lecture with the hexadecimal expansion of pi. If you want to see the digits of pi really as a sequence of integers, then here is how you can do it. You can build the string representation of pi, and then in a list comprehension essentially peel off all the characters in the string. So in some sense, this is showing a type conversion, converting a list of converting a string into a list, into a sequence of characters. Although there is no character type, there are again a list of strings, and then converting back into a sequence of numbers. Now, a legitimate question here is how do you go back? So I saw from the string to the eval. Here I've broken up everything now. If you have a list of strings, you can join them. So there is the join method. The join method will take on input a sequence, or more in particular, a list of strings, and join them into one string. So there is the join method that reverts the operation that we've done here. You see that I said that string is an elementary type, but if I'm actually asking for the type of a string, you see that the class comes in here. And it could now be that this class word is something that from a previous version of Python. So, but Python is object-oriented. All right. What I was actually getting to was the referencing. So why are lists also so important? So lists are actually the prime data structure in Python because they provide the sharing of references. Also the call by reference mechanism, which is a very powerful programming concept. So we say that a name refers to an object. Similarly, so when we define x equals r, we can make a list of one simple element, or you could see it differently. You can encapsulate your object tree. So you can actually wrap it around. So you can see the square brackets now as another layer. So you have two names. You have the name of the list, and then you have the first element of the list. So that's the L not. So that's the name that refers to the object. Seems needlessly complicated, but you can actually change the content of an object without expressively knowing the explicit name of the object itself. So here we have that in our second assignment, L naught referred to the number 3. So we can change the number 3 through L, or through a reference to L. So here is so this is all done in an interactive Python session. So this is also being done in the posted Jupyter notebook. Where we do the assignment. So if you do the assignment of elementary objects, you essentially assign values to each other. So there is one very simple link that is being made. If you assign composite object, you assign references. So here the k equals L is making just another name for the same object. So we still have only one list that contains the element 3. So in some sense you could say this is very good. We are being frugal with our limited resource, which is the random access memory. But we can also do something very powerful. We can actually change the list L through another name, through k. So so as is done here, we can change L, the first element, into 4, so the 3 becomes a 4 if you like, by not using L but using another reference for the same list. This is something what C programmers can do all the time. And this is done at a very high level. So we are essentially working with two lists, but we are working with references to one list. And this will become very useful when we design functions or programs in general. All right, so we have already used Python as a calculator. Let's now try to go into some programming. We build programs from functions. So functions are, if we are mathematicians, functions are defined mathematically. So here we have a function which squares the value of its input. So this can be defined by just one line with the lambda. Lambda is a predefined keyword. So we define the function fun that will take on input a number, and that will return the square of the number. With the keyword def, we can define a function the long way or the more general way. So a function takes an input argument. Here we call it x. It has a documentation string. The documentation string is optional but very strongly recommended. So here you see the string has triple quotes. We could have used a single quote as well, but triple quotes are strings that contain multiple lines, so can contain entire paragraphs or even more. So the documentation string will also show up when one requests help on the function. So here this seems quite idiotic even to have a documentation string, but as a programmer you write code often for other people, and the other may also be yourself in 10 years from now. Be kind to your future self and write documentation as much as possible, because what seems obvious today to you is not so obvious when you return to it 10 years later. So here we have it. We have a simple function, our first function, defined in two ways. Now, what was the fuss about referencing? Well, by default, a function is what a mathematical function is. It returns a value. Here you see the result of 3 to the power 2. But you can also pass a list. So the argument of function can be a list. It can also be a dictionary. We will see other applications of this. And with this list, you can assign to the first element the not. So there are a lot of things that are happening here. I have the board behind me, and I'm now actually very tempted to do that. So I did not prepare this. Okay, so let me improvise here. So I have, what do I have? I have the L. The L, if I had a pen that was working, then I can do this. I have no pen that is working. Okay. No pen that is working. Everything is dried up. So forget this interruption. So the L refers to the list 3. During the call, there is the formal parameter arc, which is a reference to the list L. So if we scroll back to the previous session, we had the K. That was another name for L. So here arc is another name for L. So the arc only lives at the moment when we have fun with L, when we do the function call. So the function call here is fun applied to L. During that moment, arc refers to L, and we are changing the content of arc by the assignment to its first element. So we change the list L. Actually, we do not change the reference. The name remains, but we change the content. So this is still very important. As a programmer, you must be aware that there is a difference between the name and the object it refers to. It's very important that you realize what is the type, what is the class in general. Is the type just a number, an elementary value, or is it a composite object? Where the call by reference makes sense. And here you can see the powerful mechanism of call by reference. So one does not make an entire copy of the entire data set. So the list L here in this example was just one simple number. In practice, the list could be very huge, could be a large data set, but you can still manipulate that large data set via its references. And I should actually have pointed out that there is the copy module. You can make a deep copy as well. Sometimes, so this is extremely powerful, but also extremely confusing if you do not properly realize what type of variable you're dealing with, if the variable refers to an elementary type or to a composite type. Okay, so I will shift object-oriented programming to the next lecture, but be aware that Python is object-oriented. The object-oriented programming is actually a topic entirely worthwhile one course. So Python does not force you to do object-oriented programming. One can write very high-quality programs in a modular fashion without having to resort to object-oriented programming. But every composite type is actually also a class, as we will see later on. So you can sort the list. In a way, teaching programming is easier, but then also harder. So there is the built-in sort already on any list. So you can sort the elements in a list, but sort is a method that is applied to an object, to an instance of a class. So we will make that terminology more precise next time. I'm just illustrating here that if you want a function, so and the Jupyter notebook contains actually the error message that you will see if you want to sort, but you can define your own sort. Just to make the point here, with a one-liner, you can define a function that sorts the elements in a list. It is an in-place sort, as they say. It changes the content of the list. So it's not going to make a new list. All right. I am running out of time. So I mentioned the writing of programs. You can, most programs are just not done the way we have seen here, just by typing in some instructions. They will collect it in files, or now also more in the Jupyter notebook. So in the Jupyter notebook, there is no main program anymore, but in the top-down functional design, we always have the gathering of the input, which is the prompting of the user. Then we compute something, and then we output something. So any program can be decomposed in a top-down fashion in these three elements. So you think about the parsing of the input, the representing of the output, and intermediately you have the processing. We store those functions in files, and modules can be seen as collections of functions. We will use modules. We have already the time module, we have the map module, the built-in modules. Then there are also the packages, which in some sense are collections of modules. Okay, so then one last thing. So one can program in Python as one programs in a conventional programming language, which I would definitely not recommend. So that's why I introduced the data structures first. List comprehensions are extremely versatile and extremely powerful. Also, dictionaries, know that they are there. So there are style files. So here there are these style guides. The L is very confusing. Please use uppercase L. Zeros and O's are confusing as well. Be careful about this. The Python style guide will recommend naming conventions. And there is PyLint. So compiled languages have the advantage that they do a lot of checking before execution. There is PyLint, which is a static analyzer. and that will actually help you. It can also be a game. You can it gives a score at the end, and I will tell you, if you are just coding along, then the score that PyLint gives you can be quite disappointing. But it will, at the same time, it's a dynamic way. Instead of reading the entire style guide, just install PyLint and run it on your Python programs. So there is an entire tool set that helps you out designing code. So there is, by the way, also the idle, which is the integrated development environment for Python code, which also helps you with writing better code. So we are using the Jupyter notebook now because this is helping us to document our computations, but the idle, the integrated development environment is definitely also recommended if you are starting coding. It provides you with an extra layer um, between you and the interpreter. All right, there are some exercises. So the exercises are kind of ad hoc. So if you have learned how to program at this point, you will realize that 3 exercises will not do it. Also, if this is indeed your very first encounter with programming and with programming in Python, know that we have an entire course to get familiar with Python. So please do not get discouraged, as this is too overwhelming. Then at the same time, this first exercise is a mathematical modeling exercise about the optimal temperature, the optimal formula to boil an egg. I do it, so it says how to cook the perfect egg. I can only, for speaking for myself, I only know how to boil things. I do not know how to cook, and even for boiling eggs, I have a special device for this. But this scientific formula here gives you some feedback. If you have the units wrong here, and if it takes 3 days or 3 milliseconds to boil the perfect egg, you are wrong. So translating a formula into actually formula translating, it's Fortran, the name of a programming language. So the way to start programming is translating formulas. So it's essentially, this is the purpose of this exercise. In this exercise, you can submit a script, but all homework has to be submitted as a Python, as a Jupyter notebook. So here there is no main function anymore. So just you can define a function, or just set the variables in one execution cell and then evaluate the formula in another cell. Okay, so I did not say much about using a Jupyter notebook. Please look at the example that is posted. A mistake that many beginners make with the Jupyter notebook is that they stuff everything into one cell. You can do that, but it's much better to have one computation in one cell. Formulas. So the third exercise is also an alternative. So here the exercises are listed in arbitrary order. So you may be more familiar as a mathematician to start with. So the first exercise is if you care about mathematical modeling. So the third exercise might be a better starter from a mathematical perspective. The second exercise is perhaps the hardest one, but if you come from numerical analysis, you can question how good are the mathematical libraries. So here you see the cosine. And now I stop this recording. I do not want to go over time.